Hello everyone, welcome to this video. In this video we shall be looking at this Lagrange's method of undetermined multipliers, which is an application of partial differentiation. So this method forms an application of partial differentiation. And this is our last the last application that we shall be discussing here. So this method is a very popular method, Lagrange's method of undetermined multipliers, and this is usually applicable whenever we are to find the maxima or minima of a certain function. So when can we use this method? So this method could be used whenever you are given some function of x, y, z. It could have more variables as well, and the given variables x, y and z, they are not given to be independent. Say they are defined through some relationship x plus y plus z is equal to 0. So that means at least one among these is depending upon the other two. So they are not independent. So what does this Lagrange's method does? It does not allow us to find exactly whether there is a maxima or minima, but we can use this method using whenever there are some physical restrictions on the given problem. So that means whenever some physical considerations of the problems are being discussed or are being given, we can use in that case the Lagrange's method. So what does this method say, or how do we use this method? So suppose this function f of x, y, z is given to us. So what we are seeking for a maximum or a minimum value of the function. But in addition to this function f of x, y, z, we are also given a restriction or the constraint on the function, which relates these three variables x, y and z. So let us for the time being name this to be the function phi of x, y, z is equal to 0. So here, what is the necessary condition for this function f of x, y, z to have maximum or minimum? The condition is that its first derivative should be equal to 0. So this we already know that this is the necessary and sufficient condition for the necessary condition for this function to have a maximum or minimum value. Moreover, you also know that what is the complete derivative of some function. So suppose your function f is defined to be some variable x, y and z. In that case, your complete derivative in f could be defined as del f by del x dx plus del f by del y dy plus del f by del z dz. So in other words, we will say that this df is equal to 0 in this case. So we have this condition that del f by del x dx plus del f by del y dy plus del f by dz is equal to 0. So let's call this as equation number 1. Equation number 2, this is our equation number 1, the given constraint equation. Now what we can do, we can take the derivative for equation 1. So that means if we are given this phi of x, y, z is equal to 0, this is the given relation. So once you differentiate it completely, so you will have again d phi is equal to 0. And what is d phi? D phi is this quantity del phi by del x dx plus del phi by del y dy plus del phi by del z dz is equal to 0. So call this as equation number 3. So next what we are doing, we are multiplying equation 3 by lambda, which is an unknown quantity, and it is an unknown multiplier and usually given by this name Lagrange's multiplier. And once you multiply this equation 3 by lambda, you will add it to equation number 2 such that the terms becomes this. So you have lambda into this term plus this term. So you have del f by del x plus lambda del phi by del x into dx. So this is what you have. And similarly for the second term corresponding to dy, you have lambda del phi by del y plus del f by del y. And for the third case, you will have del f by del z plus lambda times del phi by del z dz is equal to 0. Now here in this case, if this thing is equal to 0, so equating the coefficients, because on the right hand side you can write this to be 0 dx plus 0 dy plus 0 dz. So when you equate the coefficients from here, you obtain this first factor equal to the 0, the second factor as equal to this 0, and the third factor equal to this 0. So you have these three equations. So you have del f by del x plus lambda del phi by del x is equal to 0. This was the function for constraint, and this f, that was the given function. This was the given function whose maxima or minima was to be determined. So let's call all these as equation number 4, 5 and 6. So now we can use all these three equations in addition to equation number 3. What was that? Equation 3 was the derivative of the quantity of the given constraint. So the derivative of the given constraint along with these three conditions can be used to determine all the values of x, y, z as well as lambda, because here in this case we have 4 unknowns and 4 equations are there. So corresponding to these values, whatever values you will obtain, we will say that corresponding to these values, the given function has either the maximum or the minimum. Now in this case, you actually do not know exactly what is at this point, whether do you obtain the maximum value or the minimum value, but you are certain that this is the critical point where you have your extreme value. Okay, so let us now discuss several advantages and disadvantages of using this method. So here you can say that the stationary values can be determined using these 4 equations I have just told you, the constraint equation and these 3 equations. However, we do not explicitly calculate the values of x, y and z, but also, so that means in some certain applications, if you are only interested to calculate the maxima or the minima, so you do not have to worry what is the values of x and y. And the second advantage is that it can be extended to functions of several variables. So suppose you have n variables and you have many more constraints than just one, so this method is quite useful in so you could use it for more complex real world problems as well. And it is a very popular method where you are to find the maximum or minimum. So many researchers use this method to calculate the for the optimization method, where you are required to calculate the maximum or the minimum value. But the disadvantage of this method is that what nature do the stationary points have? This information is not obtained from here, whether we have a maximum or a minimum or a saddle point. So this behavior is not known by this method. Moreover, these 3 equations, they are only the necessary conditions and not the sufficient conditions. Therefore, we could use it one way only. So let us quickly discuss the method. The method says that if f of x, y, z is any function connected by these 2 constraints, suppose 2 constraints are given for this particular function, then in this case we have to find the maxima or the minimum value for the given function. So what we do, we define another function capital F, which is defined to be the given function plus lambda 1 times the first constraint and lambda 2 times the second constraint. Now what are these lambda 1 and lambda 2? They are the multipliers and they are basically the constant quantities. They are constant quantities and they are known as Lagrange's multipliers. And these lambda 1 and lambda 2, they are independent of x, y and z. So here in this case we will have 5 unknowns and 5 equations. So remember that thing. So next step would be to calculate the first order partial derivatives of this newly created capital F function and equate them equal to 0. So we'll equate these equal to 0, right? And then we will solve these along with some constraints for the parameters lambda 1, lambda 2 and for the critical point. So that means we'll evaluate the values of x, y, z, lambda 1 and lambda 2 here. And then we will find what is the value of the function at those critical points. So that will give you the maximum or minimum value of the corresponding function. So in the next video, we'll see some problems related to this topic. Until then, have a nice day. Bye bye.